We're talking about the shape of a kite, and we want to apply properties of kites. PQRS is a kite. Use given information to solve each problem. So number 10, here it has find the measure of angle PQR. Find the measure of angle PQR, which is this angle right here. If measure of angle PST, so PST is 68, and the measure of angle TSR is 63. And this is number 10. So in this case, we know that kites have one pair of opposite angles are congruent, and this is that congruent angle right here. So it's simply all we have to do is say that PQR is equal to those two angles added together. So for number 10, we can just say PQR is equal to 68 plus 63. So the measure of angle PQR is equal to 131 degrees. The next one we have is number 11. And in this case, it says find the measure of QPS. QPS is that angle right there that we're trying to find. QPS is this angle right here. And we know that the measure of angle PSR is 116. So PSR is 116 degrees. So because that is 116 degrees, that means that this is also 116 degrees because it has one pair of congruent angles. And it says measure of angle QRS is 74 degrees. Measure of angle QRS is 74 degrees. So all of the angles of a quadrilateral add up to 360 degrees. So for number 11, we do not know what QPS is, so we can say 360 is equal to 116 plus 116 plus 74 plus x, because we don't know the one angle. We add those all together, all the constants, and we get 306. Subtract 306 from both sides, and we get x is equal to 54, or the measure of angle QPS is 54 degrees. So the measure of angle PQS is equal to 54 degrees. And this one was number 11 over here. Number 12, find the measure of angle PSR. So we want to find the measure of angle PSR right there. So this is PSR. And we do know that these are congruent. We're trying to find that angle. And QPS is 48 degrees. And QRS is 62 degrees. So if we don't know what the angle is, we can represent it with x, but because we know that those are congruent angles, we can set them both equal to x. And this is number 12. So number 12 is similar to number 11. All the angles of a quadrilateral add up to 360 degrees. So we can say that 360 is equal to 62 plus 48 plus x plus x. We can combine our variables into two x's. We can combine our constants to 110, subtract 110 from both sides, and we get 250. Divide both sides by 2, and we get x is equal to 125, or measure of angle PSR is equal to 125. That was for number 12. And then number 13, what is the value of x if QT is 5x plus 3 and QS is 56? So for this one, we can say QT is 5x plus 3, 5x plus 3, and QS is 56. And QS is 56. So that full length there is 56. Well, we know that one set of diagonals is bisected, so we can say that these are congruent. And for number 13, well, that was number 14. So number 14. So we can say that QS is equal to QT plus TS. And so right there, we can say, we can substitute that in, that QT and TS are both 5x plus 3 and 5x plus 3. So we get 56 is equal to 5x plus 3 plus 5x plus 3. Combine our like terms, so we get 56 is equal to 10x plus 6. Subtract 6 from both sides. And we get 50 is equal to 10x. Divide by 10, and we get x is equal to 5. And that was number 14. We get x is equal to 5. For number 13, it says QR is equal to 4x minus 7. So QR is right here. That's going to be 14x minus 7. And RS is 7x. And RS is 7x. And we know that consecutive sides are congruent. So we can mark that with 3. And we can mark this with 3. And with number 13, because they're both congruent, we can simply set them equal to each other. And we get 14x is equal to negative 7. 14x minus 7 is equal to 7x. We can subtract 14x from both sides, and we get negative 7 is equal to negative 7x. Divide by negative 7, and we get x is equal to 1 for number 13. So 13 was also with that picture right there, and we get x is equal to 1. We got 15 and 16. If QT is 7 and PT is 24, find QP. So if QT is 7 and PT is 24, then it says find QP. Find QP, and that is right there. So we can see that this is a right triangle. So we can use Pythagorean theorem. We have that triangle right there. So for number 15, we can use, I drew another picture and made it a right triangle. So then we have a squared plus b squared equals c squared, where a is 7 and b is 24. We square both of those, we get 49 plus 576 equals c squared. 49 plus 576 is equal to 625. And to get c by itself, we take the square root. So we get QP is equal to 25. And then for number 16, we said QP is equal to 25. And that is going to be 15. And then also 16 is going to be with this drawing as well. And it says RS is 10. So we'll put X equals 25. So it says RS is 10. And then ST is 6. What is RT? So we have X there. And we can see that we have another right triangle. This one's right here. So we can use Pythagorean theorem again. But this time we are given the hypotenuse in one of the legs. So we have to solve it a little bit differently. And so for 16, we're drawing b squared plus a squared equals c squared. B squared we don't know, so we're going to leave it as b squared. Substitute the 6 in and the 10. And subtract. So then we get b squared equals 36. B squared plus 36 equals 100. Subtract 36 from both sides of the equal sign. And we get b squared equals 64. Solve b, so we got to take the square root, and we get b is equal to 8, which means TR is equal to 8.